And we are recording. This is the evening of Python coding. Welcome. We've been doing the evening of Python coding for about a decade now. This meeting actually starts the 11th year, which is something I'm very happy about. So today, the fact that I will be speaking and I'll be giving the demo means that we had some sort of scheduling issue, which happens every once in a while. So whenever it happens, then I'm giving you the demo. So you don't have the greatest and best, perhaps, but you have me. My name is Jacob. I'm a sole proprietor. I develop disease models mostly and dabble with some AI, mostly for clinical data. I have patents on disease models and stuff like that. But I also organized this meeting on a volunteer basis for about a decade now. The equipment that I'm showing stuff with today is from my own business. I'm able to do this because I have a business, so I have lots of equipment to stream stuff. But also, this is thanks to streaming. For example, the internet now is provided by my building. I am now broadcasting from a shelter in Israel. We're under a war, and in case there will be missiles here, people will be coming from behind me into the shelter, and you'll see it filling in. So this is just a whole spiel about what I'm going to show you today. I'm going to show you today a library called PyTorchLightning. Each time we have a demo, we show some sort of library, Python tool or library. Today it will be PyTorchLightning. I prepared this demo about a year and a half ago, perhaps 3 years ago, just so to show it to some people, and then later on to show it here at the evening of Python coding. And it was a backup talk. Today I'm giving you this backup talk. You can find information on my on the GitHub page. I'm going to show it to you now. Give me a second. I want to share my screen. So I'm going to share my screen. And here you see my screen now. And now I will show you where you can find it. So it's under GitHub. Look for my name, Jacob Barhak, and PyTorchLightning. This is the link here. I'm actually going to post it here, so you'll have it. You'll have the access to the code. Give me a second to keep. I have to find the cursor. It's kind of hard in this environment because the screens are funny, how it's all set up. There we go. So this is where you can find the code and you can follow it. Notice that I put the code under a CC0 license, meaning there is no copyright. You can butcher the code, do whatever you want with it. There is no copyright here, or at least it was waived out. Okay, so what is PyTorchLightning? Someone had just asked me a little bit ago. So let's explain what it's used for. It's used for AI, or more specifically for designing neural networks. But you probably heard about PyTorch and TensorFlow. Those are two libraries that handle how you code neural networks in the computer. And PyTorchLightning is basically an extension to PyTorch. Now, there are two basic approaches. The PyTorch approach is it allows you to be very particular about how you design your neural network and what it can do. But you have to write all the code. TensorFlow took the other approach where we actually take blocks and put it together in a way that is very easy, very convenient, and very standardized. But there are some things that are harder to do there. And in the past, it was less attached to Python. It was always had a Python attachment, but it was kind of less. In newer versions, it has eager mode that allows you to attach value. But this is TensorFlow. So we have two paths. One will go with TensorFlow, and one will go with PyTorch. Basically, TensorFlow will start with Google, PyTorch start with Facebook. Today, I don't know who kind of owns it, but this is in the past. It's both for open source projects that are used a lot. So we covered PyTorch a few years ago, and I believe we covered TensorFlow as well. If not, we'll cover it in the future, even Python coding. But why do we need PyTorchLightning? Well, since PyTorch, you have to write all of the stuff, and you end up with doing a lot of the grueling stuff on your own and write a lot of boilerplate code. Well, it's less easy for people who use TensorFlow before that are looking for the shortcuts. Well, PyTorchLightning provides some of those shortcuts. It provides a class that allows you to speed up many things like training, and it has most of the boilerplates you need, and it makes the world much, much easier on you writing all sorts of like code again and again and again. So this is why it's good. I'm showing the website of PyTorchLightning so people know where to find it. Now, let's go back to our demo. Our demo is about, I'm going to show a simple classifier neural network, and I wrote it in a very general way, meaning today I'm showing it's working on some fake data of landlords. I created fake data of landlords, and what I'm going to show you is how I'm going to create and train a neural network that classifies those landlords. And I'm going to use PyTorchLightning to actually do this in an easier way. So let me show you first the data from the landlords. So I have a data of landlords, fake data. I created it using Faker, which actually was presented in the past. And I created some sort of classification. Let me explain what's happening here. You have the name of the landlord, the number of homes he owns, the minimum value of the home, the higher value of the home, and some sort of evaluation of total, how much money does it have, and some sort of specialization is like all sorts of things like whether the person does high-rises, offices, apartments, farms, whatever types of houses or of real estate that they own. Now, according to all of this data, every landlord is classified as being either a risky investment, a normal investment, or adventurous investment. There are all sorts of like if you want to invest in this landlord for some reason. So think about it as it's kind of like an investor trying to invest in some landlord business and getting into this and trying to figure out whether it's a risky move, whether it's a normal move, or just adventurous, like different levels. And there's also unknown here. I don't see unknown, but it can be possible as well. So this class is how we classify the data. Now, notice I'm showing here landlord data, which is fake, but many times in machine learning or AI, we are getting the same problem that's called classification. That sometimes you just want to ask two classes. You have yes or no answer. Like if something is dangerous, then it's a yes or it's a no. That's a classification task. Sometimes you have like yes, no, or an unknown. Then you have three classes. Basically, you're asking the machine to map the records into some sort of integer that tells you 0, 1, or 2, or X, or n classes that tell you something about it. Now, classification can be used for other things like, giving a grade like A, B, C, D, whether a test was made good or bad. But it doesn't matter. The task is called classification because we don't ask the machine, the AI, to generate anything. We just ask it, here's data, classify it according to classes that we defined for you. To do this, we need to do usually several steps. So let's go back to the steps and show you what they are. So first of all, you have to load the file. Then after that, we create a neural network or load the data into a neural network that you created. And we will create it using PyTorchLightning. Then we have to train the neural network according to the data. So maybe I should say that before we don't load the data, but we actually trying to fit the neural network and set it up so it can accept the data. I'll talk about it later. You have to make sure that the data definitions are right. I actually wrote something automatic that will do it for us. So tomorrow you can take this code and run it on some other CSV file that you know where you want to classify, and with very small tweaks, without even changing the code, you might be able to use it. So I'm giving this code freely. You can play around with it and do it yourself. And if you find some bugs, let me know. I'll fix it. But pretty standard. It shouldn't be that hard. Or if you want to expand it to do something more interesting with it, go ahead. So we get to the point that we have a neural network that is set up to accept the data. Then we train it. Training means we teach it the records. We show it this landlord, and then we tell it this landlord is risky, this landlord is normal, this landlord is adventurous, and so on and so forth. We do this many, many, many times, and then the machine learns. It's being trained on the data. After we've done that, we can validate the data. Usually when you train, you separate into some of the data you don't train, so we can test on it. And you can, this code will do this as well. Now, also, the code will put checkpoints on the data. Because we're using PyTorchLightning, it's very easy that we have boilerplate code that says, oh, you know, every once in a while, save during training, save this neural network somewhere. Well, whatever you train, save it for now in case, you know, there's a power shutdown or some other error or whatever, then you can continue from the place you left off because the code will be there. And finally, we are going to run a validation and test the data and see how accurate we are. But actually, at this point, we're not training. We'll just pass the data on the files we had before to see actually how well we trained it. There's a way to actually do it partially from within the code, but we're doing it externally in some other not during training, we're doing it as a separate path. Why? Because basically it's the same as inference code. Inference is where you ask the neural network after training, you ask it what's this data, to ask it to classify certain types of data. So we're going to show all those processes. I'm going to start to show you the configuration file, but there's a requirements file to install everything you need. You basically use the requirements file, you pip install everything. It's a pretty standard operation. And the important file where you actually will be messing most of the time is the configs.json file. It's a JSON file, and this is what I'm going to show first, that has all the things you need if you ever need to tweak things without changing code. And most time, it's a good idea to write your code in a way that you have a configuration file and you have the actual code. And then if you need to change a parameter, you change it in the configuration, and then you don't touch the code. So I'm going to show an example how I do this. So here is the configuration file. Notice it's a big dictionary in JSON format. For people not familiar with it, a dictionary is where you have keys and values, and usually it's like this curly brackets is how you start telling that you have a dictionary. And sometimes you have like a dictionary within a dictionary, like model layers is a dictionary within a dictionary. And then you run the code. The code is here, and you have it again. It's called demo, demo.py, and you have it in the GitHub. You have all those files in the GitHub. So you can use them. You can actually download, install stuff, and run it just like I did. It should work. If there's a problem, send me an email or something. I'll try to help, or put the issue on GitHub. I'll fix it. Okay, so let's start with what's happening here. So I'll go over the configuration file so you'll know what's happening. The log file is where actually log everything, so you'll have X. It will show up on screen, but sometimes it's a good thing to have it as a file. So log.txt in my case. Random seed, in this case, it doesn't matter much. We don't know much with random, but you can set the random seed to something if you want the things to be constant. The number of records, something we no longer need. I should have deleted it. But we do have 1,000 records here. Basically, it's how I generate the fake data. There's a data file name called fake landlord.csv. I showed it to you. So this is what's going to be loaded into the machine for the demo. Then I define something called model layers. I'm not sure how many of you are familiar with neural networks, but today neural networks have, like many of them, have basically you have inputs and then you define, they get data in the form of a vector at the input, and then they go through computation through layers. Layers have many elements of different types, and this is how you define them. And then each layer that you go through, it actually will generate new vectors that will feed until you get output in the last layer. And that output is usually, in our case, it will be the classification code, and the code is translated back to the text like risky, adventurous, normal. This is done almost automatically by the system. So let's see what we have here. So here we have multiple layers. We have normalization layers, a linear layer, which is you get the data in. And notice that I have things like $input size. This is something that you'll see later. I put in some things to make it easier for us to design the neural network without changing the code. You just design the configuration file. It's something I do many times. It's easier because then you don't have to change code. You can go to configuration file, change a few things, and all of a sudden you have it all working with the same code. The important part is you have activation layers, value. Basically, both of these are like combined are a dense, what's called dense in some other, in like TensorFlow. Again, we have another layer of linear plus value altogether. It's kind of another dense. And here, this is how many input features we have, meaning how many perceptrons will be in that layer that we're going to use. So, and then the third level is when you put in the out features. Here you can say how many inputs are, how many outputs are there in this linear layer. It's in the dense one. And here we get out of the number of features. And here you notice I say $number of classes. And I have $number of input size. The input size is the size of the vector that we're starting with. This later will be automatically translated by the machine. Later on, I define how this model will be optimized during, these are parameters of the optimizer during training. We're going to talk about later. But this is more important. The data itself that goes into the neural network has to be defined in specific ways. I wrote some code to make it automatic so I won't have to mess with it too much. Otherwise, you have to say this column, let's say here, this min value column, how does it transform to a vector? And you want this vector to be between 0 and 1 or between -1 and 1. And if it's not, then it makes the training process much harder. So you have to convert all of those numbers into some sort of record. And notice specialization is actually very special because it's actually you have to convert this text, and this text is actually composed of things like high-rises, offices. So basically it's what we call the one-hot data or binary data, which you actually, multi-classes. You have several classes here, and you want to transfer those multiple classes into one hot representation or multi-class representation. So the system will do it for you automatically. We're going to show it later, but you have to actually figure out how to do it. So now this is how I define. So for each column, I tell it what to do. So number of all homes will be automatically. Auto, you will see later, basically it will normalize the numbers between -1 or 1 or 0 or 1. I will have to look at the code. Min value, max value, all of those columns are numeric. Those are easy. You just compress them and put them to be, basically you scale them to be between a certain number, usually around between 0 and 1 or -1, 1, depends on what you want to do. This specialization, you're using something called multi-label binarizer, which I defined in the code. Basically, it will do the work for you. So if tomorrow, instead of high rises, you want to do something else, then or some other classes, this will do it automatically for you. But you do have to define for each column, how is it converted into a vector? This is something we need to do to explain the machine what to do. And a lot of the magic that happens in AI is how you define those things. Finally, you define the class. The class is basically the output. And in our case, it will be presented as one hot. One hot is a way to say that if you have a class of 3 numbers, then basically 001, 010, or 100 will be full representation. If it's 001, this means only the first element, or actually the third one, 001. The third one, if you are at the third element, let's say risky is the third one. If you go alphabetically, then the 001 will highlight 1 if you have risky. If you have adventurous, it will be, because it's the first one alphabetically, then it will be 100. And normal will be 010 because someone in the. This is what one hot means. You can change those things and do some other things, but this is basically how it's done. Load model means if you have a previously model that you have created, here is where you define the file name. If it's null, this means start from scratch, start with a new model. These are the training parameters. I won't go into this. It's not that interesting for you. The trainer, I tell it to train on CPU. If I actually have a GPU here, I can ask it to run on GPU, but it doesn't matter much. It's a small model. It will be faster regardless. It becomes important with larger models. GPUs are much, much faster. Then the train categories I'll explain later, but basically you split the data into training and testing later on. This is how you give them the names. Checkpoint is how you save during training the model. Every once in a while you put it in, this is under what file name, under what directory path, and so on and so forth. And finally, we have validation. Again, we have the train on landlord, train and test, just like here. And this says validate on those data sets that will create and tell me how good or how bad it was. Here we have to tell it number of classes because it needs it, and how to save it eventually. This is to show you the inference data. So all of this is the configuration file. There's a lot of parameters. I skipped some of them. Many of them don't matter to the level of what we're showing in the demo, but just want to show them. Now let's look at the code. Again, the code is under CC0. You can butcher it as you want. I have no attachment to it. Take it, do something nice with it, or just play with it. Make a big project out of it. I don't care. So first thing is we have to load the configuration. So we load the configuration, and we also set up logging at the same time. So this is something very basic. When I write code, I always write this part that will load the configuration, and now we have it in something called config. And notice most of the functions will just get the configuration into them, and then later you look for the parameters you need in the configuration. It's much, much easier to write program flow, but rather than write all the parameters, because this way it's much easier, and also easier to change if you need it. So I write code. Many people prefer some other things, but everyone does their own. Then I'm going to load the fake data. Again, the data I have here is fake. I generated it just fakely. You can put real data if you want. Can change it to say load data instead of load fake data. So pretty straightforward. Open the file and return the data frame, pandas data frame. Now, here is where PyTorchLightning starts. Notice, this is a class. I call it sequential model because this is something called feed-forward model in neural networks. It is a sequence of operation that starts from input to end. The data just goes through the layers until it reaches the end. But here is where PyTorchLightning starts. You see, this is PyTorchLightning. PL stands for PyTorchLightning, and this is part of a module. This means that there's a lot of boilerplate code behind it. What we're doing is we're overriding some of this code. And this is how we define basically the neural network. If you use TensorFlow, it's much easier with TensorFlow defining a network. Without TensorFlow, with PyTorch, you'll write much more code. Sorry, unless you use PyTorchLightning, you will write even much more code. PyTorchLightning compresses the amount of code you need to write to something really small and gives you a lot of things as a byproduct, like the ability to save stuff. It's something that's already someone has already written. So here, remember, I did everything kind of when I created this neural network. I said, okay, I want to define the neural network structure in the configuration file. So I have to kind of unravel it. So here is, notice, I have like supported layers. I'm supporting linear, review, softmax, layer no. Tomorrow you can add something else, some other layers that exist in PyTorch. Here are the layers in PyTorch. The next thing I'm going to do is I'm going to start with the layers and actually define the neural network. You remember that I had in the layers, I had always a type thing. Here, I'll show you the code. So the layers, notice I have a type of a layer. So this means what kind of layer I'm going to use. And then things like the shape of the layer, you always have to tell it how many elements. But notice here in the shape, I have a string. It says input size. Input size is something that's defined actually by the data. Depends how many columns and rows you're getting. So here, and actually not only this, and how you converted it into vectors. So all of this is something that you will be getting externally. So I didn't want to give a number and then later chase it and run in the code. So I said input size, and it will calculate it for you according to what it knows. So here are the layers. Oops, we don't need this for now. Here are the layers that will go name by name, and then we unravel them and look at the parameters, understand what the parameters are, and then we substitute the text with something else. Let me show you how it works. When I call this function, actually, let me go up. So not in prepared data, not this. When I initialize the sequential model, let's find it here. Then I tell it, here's your configuration, which has all the data. But then so I have a substitution dict. Substitution dict has parameters that will replace input size with the prepared data, the shape of the prepared data after I prepared data. This is going to happen later on, but I'm showing you to now so you understand what it comes. And also, number of classes is something that can be understood from the classes. Classes is how many classifications we have in the end. Like In our case, it's free. It's adventurous, risky, and normal. So this basically the size of the input and the output will be something that the system will be able to replace with the correct numbers calculated for you. Otherwise, if you try to do it yourself, you'll find out many times, half of the time, chasing those neural networks is figuring out all those numbers to be correct. I'm avoiding this kind of like messing around by having this automated for you and all in the configuration file, so you won't have to mess with it. So let's go back to our code. Yeah, need this now. So we now substituting in all those values with whatever is necessary. It basically passes everything, and then eventually it creates the correct layer. Okay, it creates the layer according to the functions. Notice we have the layer function is something that is one of the supported layer according to the layer type that we define. And then we use the layer parameters we have already replaced with the correct numbers. So now eventually we have a PyTorch model, which has the correct layers, and we put those layers where they're supposed to be. Now we've created the neural network after running throughout this code. Now we have to define some other things that are basically basic boilerplates that happen that you need to do in PyTorch all the time. One of them is forward. It's like saying, okay, now run the data through the network. So forward takes the data X and runs it through the network. And what it does, it's like for each layer, it applies the new layer on X and and basically gets the X. And then again, does for the next layer and so on and so forth. Basically, it propagates the data through the layers until you get the output data. And then you get X returned for you, which is the output in this case, and this is the forward operation. In the training step, you actually have to calculate several other things like the loss function. I won't go too much into details, but you have to do this and the loss and so on and so forth. And then eventually you have to report it to the log and so on and so forth and return the loss. This is what happens during training. And the validation step, you do something very, very simple, very similar, but you have to give out not the loss, you have to do the output, the inferred class, and the target, which is basically what you get from the batch. A batch is like, for those who are not familiar, when you train a neural network, you have a certain batch size of data. Let's say 3 records, 16 records, 12 records. Can be 1,000 records, depends on how much you do, but usually you keep it around 16 or 32, but it depends. So I've seen also neural networks do something else. So this is how we calculate the validation step, and it has to return those values. So it's kind of boilerplate. It will turn most of the time very, very similar. Your code will be very similar to every classification neural network, or very similar to this to some degree, some small tweaks. Then you have to configure the optimizers. Basically, in my case, it's Adam, but you can use some other optimizers. Many people like Adam, so we use it. And then finally, the inference itself. Once you run through the network, then you, by the way, the difference between the training step and validation step is during training, you do something with the validation. If you don't define it, you won't be able to validate the text. The validation step gives you information about how it basically runs the model during training on your test data. So this is why you need it. It's not the same as the inference, which is another type of validation, which is after the network has been trained. So now you infer for a specific record, which you provide the features. Basically, it's a NumPy array that represents your vector. Basically, you have to compute it. And it will output eventually the data in and basically it will do several other things. It will tell you, for example, First of all, it will calculate the output during the forward that we already defined. Then it will look at the probabilities of either you being risky, normal, or adventurous, in our case, our classes. But what it will do is it will run a softmax function that will tell you what the probabilities are, sort the classes, and sort the probabilities, and then figure and then assign names. The names comes, sorry, not names here. These are numbers, and then it will return the best. The best is the one that's, if you order the classes such that the highest probability is on top, which is what we do, then it will return the classes, but it also will return some other information, like for each class name, it will tell you what was the probability of reaching that class. This is useful for later on. I'm going to show you when we output the files later. So far, any questions, or did I go above anyone's head or anything? Come on. Are you even listening? Did I lose connection or anything?
No,
we are
good
listening.
stuff. Thank you.
Okay, so we're good. Okay, so if you have questions, ask. Like, the idea is it will be better for everyone, I believe, but I don't want to go over your head, or I want you to understand some of the stuff. I'm doing fairly sophisticated stuff here to make things easier for people to create a classification network only using the configuration file with very few tweaks in the code, if at all. And you can later on try it on classify something else. Okay, let's talk about preparing data. So we've defined the neural network, but there's a whole set of preparing data, and preparing data I also trying to automate somehow. So what I'm doing here, I have lots of information here, which is kind of like scary, but like, let's try to go over it and not go to too much details, but just understand what this function does. You have the configuration, which is all the parameters that you need. You have the data frame that the data frame is basically this file, just in pandas format, which tells you if something like whether a landlord, its name, whether risky, and so on and so forth. So that's the data frame. Now, previous transformation is like if you computed the transformation before, we're going to talk about what transformation is in a second, then use that transformation. Otherwise, you have to calculate the transformation and later output. The transformation says for each column name, what will be the data definitions, what's the transformation object, which is something that basically transform the data, let's say from text to a vector or from number to a vector. Those objects will be different. And then you have the start of the data column. When you transform the data, it becomes like some data points will be like one column or two. Like one column in the original data may become one or more columns in the output data. So this tells you where this start, and this tells you where you start the class column. Class column is basically the classification column. So all of those are called the transformation tuple. Also, it will give you the prepared data as a NumPy array. Feature is basically when you transform all of those stuff, you transform it into numbers, all of those columns between zeros and ones. Then this is what we call a feature, and we will have a feature vector. So this is what we're going. I'm going to skim through it without too much data, but basically you load the data. If there were previous transformations, you apply them. If there weren't, then you create them according to the data definitions. Here are the data definitions. I'll show you again, so we'll remember what they are. In our case, for each column, you tell it how to transform the data. I'll have two transformations, one of them, actually three transformations: auto, multi-label, denoise, and one hot. You can add more later on if you want to expand this code to something else. So if it says auto, then basically all of those numbers, all of those data types that are detected, then you want to standardize them. Later on, we'll explain. If your data type is an object, meaning if your data in your pandas frame is an object, this means it's basically text, then you transform it to something called one-hot. Unless you define a more sophisticated transformation. Sorry, I misspoke. If your definition is auto, then numbers you standardize, text you do one-hot to. Basically, you transform it to one-hot. Remind you, one-hot is when you have different classes, they give a vector which is composed of like 001, 010, 10. It's called one-hot because you never have a 110. It's only one, which is only one element in the vector has a 1, which signifies which class you are. It's easier for machines to understand the stuff during neural network, but today there are other techniques to do it, so I won't go into details here. So so if your data type is a float, then you basically do standard. You basically convert it into float. Yeah, someone's asking something. Yeah. Yes, Robert.
Is it fair to say that this is basically the same process as polynomial regression based on data, except you don't get the factor coefficients, but you get a model as a result that will decide the input to output function?
Okay. So, you're not talking about the data definitions that you're talking about now. I would, since you asked the question now, I will tell you what you call regression is optimization. The function you're optimizing, when you do regression, then you use typically simpler functions. When you are using a neural network, then you have a complex function that you're trying to train, and the process of optimization will find a function for you, which has many more parameters than a simple regression, which you have like several coefficients with a simple function. Here, the function is much more elaborate. So, but it has nothing to do with what I'm talking about now, which is how you construct the data. Remember, what I'm talking about now is you have this type of data and you have to convert it into numbers, typically between 0 and 1 or between -1 and 1. So the machine will be able to work nicely on it. So all of these, each record here will have to be defined as a vector of 1, 0, 0, 0.5, 0.35, blah, 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 blah. Okay? So
Jacob, yeah, I'm sorry for interjection. Actually, I talked to like lots of mathematicians. They all say neural networks, it is a form of regression. I mean, what you're running, but it's kind of like a second form of regression because you are optimizing the loss function. So you're minimizing the loss function but you're not changing parameters of the loss function, you're changing parameters of your weights. Like
yeah, the weights are actually the same weights you define here. If scheme of regression, let's say I'm trying to simple regression, I want to fit a line between points in space. So I have two parameters, A and B. Those are my weights. And I run them some sort of optimization method. Okay? In the neural network, you're doing the same, but the weights are not A and B. The weights are like 1,000 different or 100 or 1 billion different parameters, and the process of actually doing this is much more complex. Yes, they are both optimizing, and yes, if you call regression and optimization, then yes, it's the same.
But you also have a secondary function here. You're not minimizing your network, you're minimizing your loss function. So you...
this is the same thing you're doing in regression.
Yeah, no, but you're not changing parameters of the loss function. You're changing parameters of the like a first like. So your neural network is a function essentially, right? It takes an input and
it is this is what neural network should define. It basically defines a function.
Yeah.
But for this, you have to first transform. I'm trying to get back to what I was explaining. You have to transform your data to a vector that the function can accept. This is the part I'm in now. Okay. Yes, the neural network is a function. Yes, you're doing something very similar to regression, and you can argue it depends on semantics at this point. Yes, the answer for those is yes, but then again, someone will tell you no, but you're doing something different because you're using a different technique. So I'm going to go back to what I'm talking about now. I'm talking about how to transform the data into a vector, and this is why we have those data definitions. Okay, so let's go back and you remember I mentioned I put this stuff with column definition as something called standardized. If I have standardized, then basically you will be able to use something called a standardizer, which will standardize the scalar and basically transform things between 0, -1 and 1, I believe. Check me if I'm right or wrong later on, but it's a pre-processing tool, I believe, from scikit-learn. Actually, let's check it out. I wrote this code too long. It's scikit-learn? Yeah, scikit-learn, pre-processing. So basically, the standardizer is the object that will do it, and it has parameters such as like what's the lowest or what's the highest and so on. I'm also using the one-hot encoder for one-hot, if you're using one-hot, and I have a multi-label binarizer later on here, multi-label binarizer. So all of those are things that I'm done. And notice I always have, like, if I have a previous transformation, just to reuse the one that I gave you. If not, then compute with the object and then apply it to the data. Those are like, this is a repeated pattern throughout this piece of code. But this big piece of code will make it much, much easier for you to add more columns or change more columns. So for example, if I had in the landlord, here I have like number of homes, min value, max value, evaluation. This is like all numbers. But what if I had another type of data? Someone came in with a new column, let's say number of number of previous companies the landlord had. So this will be another number. Now I have another column to add. Oh, how do I add it? And it becomes complicated to compute this. In this case, I just put in the number of previous companies, and I put auto in it, and I don't have to worry about it. So if you have now a new CSV file of some other type of data, I don't know what data you want to classify, then you basically write the columns and say, this is like this is like that, and so on and so forth, and it will do it for you. Now, the one-hot I use for the classes. The multi-layer binarizer I use for the specialization. Now, although the multi-layer binarizer has some space afterwards, this is because you can add parameters there, but I won't go into details here. You can look at the code later. I just don't want to add this too much to overload the demo, because I just want to show it to you working. So, where was I? Yeah. So eventually, I gave you all the data. The output of this is the prepared data. The prepared data basically is now the transformed data as vectors. You gave it data set, appends data frame. The output will be the prepared data. The prepared classes is a different, like it separates the class from the training data. Now it comes in a different vector, because when you feed it backwards later onto the machine, you will have to give it separately. This is because you have to give it the data and then the answer. The classes basically are the output during training, because this is what you're supposed to learn. And then the transformation tuple, in case you ever have to use it again, and we'll have to use it later on for inference, because we're going to use the same data. We're going to get new data, and we're going to use the same transformation. So now we run the model. So the model starts by preparing the data. This is the function we just explained. Then you remember, then we run the sequential model, and we replace input size with the size of the data, like how many column, like what's the vector size that came out. This is how many layers, how many elements we need, nodes we need in the first layer. So this is the input size. The output size is the number of classes. In our case, it's 3, because we have risky, adventurous, and normal. So this will be all computed automatically, because tomorrow, if you give it the same data and just add one more feature that's not risky, like extreme risk or something like that, then all of a sudden you have 4 classes. Now you don't have to rewrite the code or not even change the configuration to do it for you. You actually might need to change the configuration later on one thing. In the validation, you have to tell it how many things, but otherwise it will be the same. Then we actually define the model. This is where PyTorchLightning shines. We just say the model is the sequential model. We already defined the class with all the boilerplates. And now we can load the model for checkpoint if you actually have a load model from before. But in our case, we won't have one. The data dictionary I have here is when I split data into text. Okay, also the next phase will be splitting the data into training data and test data. Once I do this, I have to save them, so I put them in the data dictionary. So if I have the train in my configuration, the train key, let me show you the configuration. If I have train here, if I define this, if I actually undefine it, that I won't have train. So I will do the following. I'm going to get all of the data and split it into test and train data. Then I'm going to save the test data and the train data in the data dictionary for later use if I want to validate against it. Then I'm going to train and test the data. I create different tensors, and basically I'm going to create data sets that wrap all this data, which are tensors. So this is going to be automatic. Later on, I'm going to load the data. Actually, I'm not going to load the data. I'm going to create an entity that will load the data into the neural network. This is something that people have to understand. When you train the data into the neural network, you cannot give it too many vectors at the same time, because sometimes you don't have enough memory. In this tiny example, it doesn't matter. You can just take all of those records and the system will not care. But with big neural networks, you may not have enough memory even. So you need to create a data load that says, oh, give me 3 records, give me the next 3, give me the next 3, give me that. And then at the end, it runs out of it and say, oh, give me the last 2. So this is the data load. You define the parameters, how to define it. You will find them in the config file. Notice this is a Python meetup. So when I write something like this, this means give me all of those as keywords into the function. So when I define this, let me just give this an example. Here. Trainer, if I actually, which one was it? This was the test data loader. Test data loader, let's find it here. It should be somewhere here. Here, test data loader. So you see those parameters are going to go into the function, and they're going to add it as keywords to the function call. It's a very convenient way. If you work at the config file and in code like I did, then you want to push as much as you want in the configuration file and write the code as easily without even having like numbers in it. So this is a very convenient way of doing this. You can't always do this, especially if you have like live objects, but this is a good technique that I find very useful. Then you have the model checkpoints. If you want checkpoints, fine. And of course, then you have all the trainer parameters. Notice this is all stuff that you had to write on your own if you would use PyTorch. With PyTorchLightning, you just say eventually fit with all of those parameters, and someone wrote the fit thing for you, and that's it. So this is where it becomes closer to PyTorch, that actually you also model.fit. Sorry, not TensorFlow. I apologize. TensorFlow is like very, very good in standardizing things. PyTorch allows you to go wild if you really want to. So it's a trade-off. Some people like PyTorch, some people like TensorFlow. There are cons and pros for each one of those. I won't say what I like. I won't bias you. You decide on your own. And then finally, in the validation step, what I do is I look at the validation. Oh, by the way, this finishes the training part. All of this that we did was all code to get to the point of trainer.fit, and this will fit our data and will generate our neural network and save it to file because we define the checkpoint. All of this is going to be done for us. And then what we're going to do is we're going to take the training set and the validation set that we defined before, and we're going to run them, but this time we're going to run them record by record. And each time we analyze the record, we are actually going to put them through the neural network, see what comes out, analyze it to the point it's saying how far we are from the class, whether we were correct, not, and how far we were, what is our error. All of this is going to be done for us using this code. So basically, I go through all the records, I load the data sets again, and here you remember the transformation. Here, the transformation is important because we already calculated it before. We just plug it in back. We don't have to recalculate it. Because this, if we calculate it, would may cause issues. Because some of the scales, for example, if you have numbers between, let's say here, let's look at the example to understand why it's needed. But here you have you have a number of homes. Let's say it varies between 5 or 3 to 30 something. 3 to 30, I don't see number. Oh, between 1 and 30 varies. But when we split the data between validation and training set, then we take some of the records. If we would normalize data that has numbers between 26 and 24, it will have a different transformation than if we took all the numbers between 1 and 30 and normalized them between the same data set. So it matters that the transformations will be the same, whatever we apply on. And once we do this, you have to save them before. If you will calculate it on the new data set dynamically, you might get a bad vector representation. Basically, you will be scaling something that you're supposed to be scaled between 1 and 30. Instead of it, you will scale it between 24 and 26 or something like this, which will give you totally different answers. And therefore will mess with the machine. So we don't want this to happen. Therefore, we feed the transformation backwards to the machine, saying use the same transformation we computed before on handling our data. And then we go for each row, we take out each record and we calculate. Where is it? Where is the calculation? So we first figure out what we expect to get, the expected class in one hot, and then later on we infer the record on the model. Remember, there was inferred record that you wrote, and you give it the features and you see how accurate it was. If the best class is the expected class, then it's accurate. If not, then not. And then you sum up how many accurate records you had and so on and so forth. And you actually write down all sorts of stuff, edit stuff about expected class and what is the original enumeration of the old class and so on and so forth. And then eventually, basically you append it to a big record and output it into files. That's it. In the main, basically you will load the configuration, load the fake data, and then run the model. And then everything happens. Now, I'm going to use PyCharm to actually run it, and hopefully we will not have, here's PyCharm. Sorry for the small print, but PyCharm, you cannot really size it. So there's a presentation mode, but then it's a mess getting out of it, and I don't want everyone to see it. So Please believe me, it's the best I could do in this situation. I'm going to run this code as is, and I'm going to look at the data that comes out of it at the end. So first of all, I'll run it. I'm going to run it for 50 epochs. Epoch is when you run all of your data set from start to finish. Notice the data will be randomized, and this is something that happens internally already. So I'm going to run it. What you're going to see here now, and hopefully it will run. Yeah. So you see here the training process. This is Torch and PyTorchLightning all together and running it. When you actually run it on not that screen, you will see all those pyramid schemes. You will see like one line for each one of those. But since PyCharm terminal outputs thing differently, you will see it as different lines, which is also okay. Basically, it shows you the progress. After about 50 times, I think it's 43, 44, we're almost done. It will go into the validation phase. Okay, and then in trend, the validation ran everything, and you have some statistics that's spreading out already. This is part of what the program does. So here, for example, we know that after 50 records, the accuracy, the overall accuracy, you had like 800 records in the training set, 703 of them were correct. Not much of a training, but it's good enough. And you got the accuracy of 87%. And in the validation set, after 50 epochs, which is usually not a lot, but it's a tiny data set. It's just for toys. So we got 84%, 84.5%. We had 200 records, 169 correct. And now let's look at the files and check them out. So this is the no. Where is this? Files. Yeah, PyTorchLightning. No, this is the GitHub. It's not on GitHub. Here we go. So we're going to run here. Let's look at the test. This is usually what happens. You're interested to know how good the test was. And give you a second. I have to bring in the screen from the other side. The screen. And I'm going to make it bigger so you can see. Now, it actually shows me some information so I can analyze whatever I did. It shows me the same for training. So, know how it did the no thing. Here we go. So let's look at this. And what you see here is the following. So for each record, it actually shows you the record. It doesn't show you the features. We can actually, in the future case, someone can actually write some code that does the feature. Notice the records are randomized. The order is different. So Daniel will not be the first record, maybe in the original data set, because everything is randomized now. So certain number of homes, min value, so on and so forth. The class is adventurous. Now let's see how it translates for us. So first of all, the expected class will be 0. Adventurous is coded as 0. Normal will be coded as 1, and risky will be coded as 2. You'll see it later. Here you see 2 is the risky, and the normal is the 1. This is the expected class. This is basically the translation of the word towards a number. In one hot representation, it will be 001, 010, or 100. Now, there is no error. But here, for example, if things are not accurate, it will tell you how far are you from your class. It doesn't really matter how far you are if you already are wrong. But sometimes it does matter, because if you have something on the scale, you want to know how bad in the scale is. In our case, yes, it's like we have normal, adventurous, and risky, which is like kind of a scale of someone being more and more risky. Then notice for each probability, for each class, we have the probability. So class 0 is our class. It says 59% accuracy. This is class 0, and in this case, it was correct. Class 1 is 40%, while class 2 would have been very, very low probability. But notice, yeah. So, sorry, here I have to explain. This is the first class. Class 0 is the first choice. It says I chose this class, the expected class in our case, with almost 60% probability. The other one's 80. The third one was very low probability. So class 0 is the probability of the highest one. So here, for example, expected class 2, you see it's 94% accurate in class 2. So this will always be the highest number. Class 2 is the second choice. Third is the third choice, and so on and so forth. The original, this is where it came from, the original data set. This is the number of the original data set, because remember, numbers are mixed and so on and so forth. So now you have information to actually look at your data. So if you have new inference data, you can feed it to the same machine under the same conditions, and you should run very much similar to what you've seen. I think I'm done with actually showing you the demo. Hopefully I didn't go over your head, because I tried to fit in a lot of stuff that is not necessarily PyTorchLightning, but hopefully what I showed you was good enough. I see someone's asking questions.
Hi, Jim. So you mentioned Best Buy in the best class, I think, in the
Yeah.
but that is not in the output.
Yeah, it's output. This is all output. This is I'm testing. This is the data set. This is the test data set. This is when I trained the data, I did not include 200 records. I had 1,000 records. 800 of them I trained upon. 200 I put aside for testing purposes. It's like, this shows me how accurate I am later on. And what I'm doing now is I'm feeding those 200 records into the system and asking, okay, you already trained on some other data, the 800 records. What about those 200 records? How accurate are you? And it shows me for each record how accurate I am. This way I can analyze and see whether I'm okay with like class risky, class normal, or class adventurous, which one of them, like, I was able to infer better. Some people say predict. I hate those words with respect to neural networks. It's not really what neural networks do. They cannot foretell the future or anything. Like predict assumes. It's more like inference. You infer something from the data, and this is what we're doing. So this is the inference step. We inferred the data, we ran it through those records into the system, but we already know what they're supposed to do, because I do know what they're supposed to do, because I'm testing myself. I know what things should be. So this is how I know the expected class. Normally, you will not know the expected class. Okay?
Okay.
Did I answer the question?
Yeah, and like as the data set size increases, it will take time to compile that code, right?
Look, it's not compile the code. For those sizes, like 1,000 records, it's for this tiny data set, it's nothing. It can be processed on my CPU easily. You saw it running on CPU while the machine was doing some other things,
Yeah.
like video and stuff like this. But if you're doing serious machine learning, you will need a lot of memory. You will need a lot of things. The models that are being trained today, this is tiny. This is beyond even tiny. This is my weekend, but it's good for an example just to show how things work. When you go today to do some machine learning or AI, then you use huge models sometimes, and then memory is an issue. And yes, size of the data set is an issue, but this is where we have data loaders, because they will take only a few records at a time, so it will fit the memory. This is why we need the data loader. But there are limitations. At some point, you'll get to the point that you will need more memory and stuff like this. Yes.
Okay.
Okay. Any more questions by anyone?
Yes, Ilya has a question. Who wrote the Lightning library itself and how big is it?
Oh my God, who wrote it? And how big is it? I don't know. You pip install it and it loads on your machine. It's not something huge. It's a little bit difficult. Who wrote it? Let's see. I have no idea.
So
Like,
is it-
I suspect it's some group from. I'm pretty sure it's. This is not that. I think I lost that. This is it. No. There we go. PyTorchLightning. I'm pretty sure it's the Facebook people, but let's see who commits. PyTorchLightning. Let's find the GitHub thing. The examples. Who wrote it? Wow.
I only asked it because I was under an impression that it was somebody from the meetup and it was their project and they were.
Oh no. This
I just misunderstood it.
No.
Okay.
Each time in this meetup, we pick up a library and we show some demo on it.
Oh, so
Sometimes
just an
it's someone
existing
from a
library.
community, sometimes someone who wrote the library and wants to show it.
Okay.
All sorts of, like, we had, like, in 10 years, we had all sorts of examples. Now, what you're asking about here, you have team management. Oh my God, they have a management site.
I mean then I can just go and look
Here,
at it myself, yeah.
look at how big of a team it is. Like,
Yeah, okay.
Organized team size, individuals, new projects, small. Oh my God. Oh, I don't know. I think.
No, this is how you organize the price. So the best way to do it is go to PyPy and just search for the PyTorchLightning, and you can. There is a site called PyPy.
Wait,
that's where the people like pulls everything from. Like
here, PyTorchLightning. Welcome to here. Where's the GitHub page? Usually they have like a GitHub thing, and everyone goes in GitHub, and then you see.
Go to PyPy, PyPI, because that's the site where everything the people is pulling from, right?
Yeah, I know.
And then you can just find the authors list that's usually there. Like
Yeah, let's do the SUS. PyTorchLightning. I apologize before the PyTorchLightning people. They do a good job, and I neglected even to see who they are. Yeah, but this is how it is in open source. There we go. And usually there's a link here to the GitHub. You see, there's William, Falcon, and Borda, which are the big maintainers. You can actually.
and there is if you click on homepage.
Here's the source code. Here's the source code. Here, all the people who committed. It's Apache, by the way, and see they have
Wow,
986 contributors.
it's huge.
You see, those are the big maintainers and how much they code in some other, and then it goes on and
Yeah,
becomes more minute.
Borda guy, yeah, you can see who that is.
Yeah. So, you want to see who Borda is? Jirka Bovek. I hope I didn't butcher his name. And he's in Prague, apparently. And let's see the other big maintainer. Give him some credit. William Falcon.
He's from Facebook.
CEO, okay, researchers, Facebook. Probably they split up with Facebook Richard because it's the CEO of Lightning AI. So Lightning is basically the PyTorchLightning. So I assume, yeah, they started Facebook research and probably started their own company. He's from New York. This is all apparent. I don't know those people. If they ever see this, then thank you for giving a nice library so I can get a demo. I needed this. It actually was nice playing with it. And it does what it's supposed to do that PyTorch was not very good at, and TensorFlow was better. So it kind of like closes the gap, and they do the correct thing. So yeah, so this is what I can tell about those guys. Anything else? Oh, by the way, we have, you see the checkpoint and the logs. This is where you can actually load the data from later on. And PyTorchLightning gives you the tools to actually do this. Actually, it's a combination of Torch and Lightning, but basically the saving there is enabled by, they made it very easy with PyTorch. Let's say it like that. You know, you can live without them and do just write in Torch, but it will break your hands. It's like, you know, it's like writing. Actually, I should take it back. Actually, writing in TensorFlow was as bad as writing in Torch, and Torch was actually better before they introduced something called Keras and introduced it into into TensorFlow. So now TensorFlow is supposed to be better because of Keras. So PyTorchLightning is probably, it's not exactly the some other things, but it's probably the equivalent of Keras and TensorFlow towards PyTorch. Hopefully, I didn't stray things too far from the truth, but this is my feeling, at least while looking at this library. It just makes easier dealing with the small little things that you should have not deal with while you're writing neural networks. Any other questions?
Juba has a question. Where will you pause the recording? It will come in an email.
What I have to do with the
The
recording?
link will come with an email.
When I'm going to pause the recording, whenever there's no more questions, I'm going to stop the recording. Do you have any more questions? Anyone? Questions going once? Questions going twice? Questions going 3 times? So if there are no more questions, I'm going to stop the recording. Usually we thank our speaker, but this time I'm the speaker. We don't have to thank me. We're good. But I do hope you like it. Oh, thank you. Some people like me. Okay, I see here. I'm probably going to show it. So I'm going to stop this, and we're going to go and show so everyone sees. Okay, I'm going to stop the recording now. If this is okay with you guys, don't go away. We're continuing this meetup. We're just gonna stop the recording. Don't go away.